Alright, section 7, partial fractions. There are 4 different types of partial fractions to do, 4 different cases. I'm going to show you just the first one. The other 3 are a lot like it, really similar. If you wanted to go through and work on those other 3, you can look in your book and figure it out, or I can help you another day. But I'm only going to test you on case 1, so we're only going to go over case 1, and I'll give you 4 problems today. They're fairly simple, but the whole concept is kind of crazy. So 10.7 partial fractions. And what it is given a fraction, and this will be with variables and stuff. I'm just going to give you this small one here. Given a fraction, what fractions were added together to get you this answer? So we were working backwards an addition of fractions problem. Okay? And so real quickly, what are factors of 6?
2, 3, and 1, 6.
2 and 3 and 1, 6. Well, let's just do 2 and 3. And then we don't know what these, we don't know what the numerators are, so we're going to give them variables. And then we're going to figure out what those are. So this is the process, and I'm going to write down each step of what you have to do that you got to kind of memorize what to do, okay? But this is the process that we're going to do. And how you solve for this is you're actually going to set up a system of equations. And you can either solve with substitution, elimination, Kramer's rule, inverses, determinants, all that stuff. However you want to do it, I'm going to tell you how to do it. Most of these ones at the beginning, you can probably just do elimination pretty quickly, okay? So this is a very basic type of problem. Let's talk about what it is we're really going to look at here. So this is called case 1, where the denominator, and this is how you can tell which case you're in. The denominator is a product of distinct linear factors. Linear, non-repeating factors.
Can you put that on our reference sheet?
Why don't you wait till I show you all the stuff and then you can decide. I mean, I don't care what you put on it as far as the notes are concerned. Why don't you wait till you look at all of it before you do that. Non-repeating factors. And this is the part that tells you what case you're on. If you look at your denominator and you look at the factors of the denominator, if none of them are repeating, if they're not quadratic, that's case 3 and case 4, then you're dealing with a case 1 type of thing. So here's what one of these looks like. So this is number 4 in your book, and we'll do another one or maybe 2 more examples. Here's the answer, x over x squared plus 3x minus 4. So what do we do with this? Let's start with the steps. First of all, who can factor the denominator for me? It's chapter 9 of Algebra 1, factoring a trinomial. Somebody factor. It's really easy.
X minus 1 and x plus 4.
Yeah, that's what that factors into. Alright, so step A is factor denominator. Okay? So what we have here is the left side is x over x squared plus 3x minus 4 is equal to these 2 factors for your denominator, just like what we did with the 6 over here. The factors become your denominators. Okay? That is step 1, or step A. Step B. Let me ask you, come back over here. How would I add these 2 fractions together? What? You need a common denominator. And what do you do with the common denominator? What's the process? How do you make it a common denominator?
Multiply a over 2 by 3 and
you multiply this by 3 and this by 2, right? Okay. Yep, that's pretty good. And then that would be your common denominator, right? This would have a common denominator, right? Okay, now, I'm just going to write this out. 3a over 6 plus 2b over 3 over 6. Can I get rid of my denominators at this point? What do you do? How do you get rid of your denominators? Multiply by the common denominator, right? Okay, so if I would have multiplied by the common denominator up here to start with, okay, let's just do that. That goes away, leaving just the 5. This becomes 3a. This becomes 2b, doesn't it? So why not just multiply everything by the common denominator to start with? That's step B. Multiply common denominator. And you already know what the common denominator is, you told me. You factored it, but that's the common denominator, isn't it? Okay, so we're going to multiply both sides. But here's what you're missing up here. What are we missing up here? We don't know A, we don't know B. Sometimes you're going to have 3 factors, sometimes you have 4, depending on the case that you're doing, really, and how many factors you have. But if you notice, these are irreducible factors. You can't reduce these. Like, let's say this came out to be x squared minus 9. That could be factored even further, right? So it can be reduced even further. So this is an irreducible factor, and it's non-repeating. Like a perfect square trinomial, those special case formulas that you had back in Algebra 1, and you factored in, this could be like an x minus 1 quantity squared. You had 2 binomial factors that were exactly the same. Those are called repeating factors. That's in case 3 and case 4. So here you have non-repeating factors, and they are not reducible. So this is why this is called a case 1. But how we add and subtract fractions are identical here. So we're going to multiply by the x minus 1 times x minus 4, or x plus 4, in every term. So is everybody following me so far? Same thing as what we did here, except now we're doing it with these factors. The common denominator. Right? Can I show you how to do it then? So this is just that, so that reduces, leaving just x. Just like that, just left the 5 over here. We multiply by the common denominator, the 6. These two are exactly the same, they just reduce off. What about here?
X plus 4.
Yep, it's going to be a times x plus 4. What about here, Dante? What cancels?
The x plus 4.
Yeah, leaving b times x minus 1. Alright, so let's review real quick. Step 1, find the factors. Now you guys remember, you got a final exam coming up. There's lots of different ways to find factors. Long division, synthetic division. You're not going to do that today. Just giving you a heads up. In the last part of the problems in today's assignment, in the book, in the section, deals with doing that stuff. I'm not giving you those, okay? But you got to make sure you can do that for the final exam. So if it says find factors, you got to remember there's lots of different ways to find factors, not just the basic way of doing it. All right, so that was B. C. What do we do at that point? Let's expand or distribute. Expand and combine like terms. So that just means you're going to distribute your A, your B, your C, your D, whatever you have set up here, okay? So x equals ax plus 4a plus bx minus b. Did everybody agree? Did I do it right? Did I drop a sign? You know how good I am at. Never from making a mistake. Anybody lost? Other than the 5 people who are going to come in tomorrow and be like, what? Now, combining like terms. You've got to get used to doing it like this. Let me just give you a simple thing to look at. If I had 2x plus 3x, what would you say that is? You'd say it's 5x, right? Except you can't see that there. But that's the same thing as this, isn't it? 2 plus 3x, isn't that the same thing? Alright, so this is how we're going to write these, because we don't know what a and b are. I can't say that's abx, because that's not right either. So I'm going to take my coefficients, a plus b. That's my combined x term. And what's left would be my constants. Now remember, these are just normal numbers that are going to be able to add and subtract together. They aren't variables. Okay, so these are my constants. They have no x's with them. So this is a 4a minus b. So you just put your constants together in your parentheses. There's a purpose for doing this. So this is something you got to kind of get used to doing. Now, step D is match your coefficients. What does that mean? That means the left side is equal to the right side. No matter what's on the left, you're going to have different stuff on the left. Okay, we'll do a problem. I'll do a hard problem next. So what I have here is a 1x equals this whole thing. Well, this should equal that. So a plus b equals 1. You're matching the coefficient. The coefficient on this x is a plus b. The coefficient on this x is 1. Match your coefficients. What's the constant on the left side? Constant is just a number by itself. Let me write it like this. 0. So 0 matches up with this. So we have 4a minus b equals 0. We'll do a 3 by 3 next. Solve the system. Substitution, elimination. You can put it in row echelon form. You can do inverses, discriminant. You can graph it if you wanted to. How would you solve this system? How about we just add the two equations? You're thinking the same thing. But if I add these two equations together, don't I get 5a? The b's cancel, and 1 plus 0 is 1. So that's why this is why partial fractions are in this chapter, because this chapter is all about solving systems of equations with matrices. So what's a?
1/5.
1/5. A is 1/5. So if we'll write right here, a is 1/5. If a is 1/5, what's b? Yeah, 4/5. If that's 1/5, this must be 4/5 to equal 1. So b must be 4/5. So you're solving the system the same way you've been solving it before. What to do is all of this stuff. Once we get to here, you pick and choose how you want to solve it. Okay? So what is my answer? My true answer really is 1/5 over x minus 1 plus 4/5 over x plus 4. And that's where we're going to stop. Technically, you don't leave a fraction inside of a fraction. This is really 1 over 5 times x minus 1, and this is 4 over 5 times x plus 4. But we're not going to go from there. If you were to actually put these two together by finding a common denominator, you would end up with where we started, x over x squared plus 3x minus 4. Alright, so that's the process. You got it all in your notes? We're gonna do a hard one. No?
Yeah.
Alright. That's the spirit. This is all case 1 stuff. Case 2, case 3, case 4, all the same steps apply. Nothing's different. Just your denominator factors into different things. Okay, let's see. I'll pick a good one. Let me pick one out here. How about we pick this is number 22. 8x minus 3 over 2x squared minus x. That's good. They don't tell you in your book what cases they are, but like the first 15 problems are all case 1. So I went through and looked through and marked them. Okay, what's the first step? Look at your notes. Factor. Everybody factor the denominator, please. Factor the denominator. Factor the denominator. What are you doing? Right on your paper? Oh, that's this right here. Oh, we did that one on the notes, right? That's what we just did. Oops. X and 2x minus 1. First two classes really struggle with that for some reason. X is the common factor. If you have 3 factors, then you're going to have 3 fractions. If you have 4 factors, you're going to have 4 fractions. Okay? First period, we actually tried to show all 4 cases. I could only get through the first 3, so I decided just to do this instead. What's the next step? I don't know my numerator, so what's the next step? What's the we know what the common denominator is. So we're going to multiply by x over 2, x times 2x minus 1 in every term. Everybody try that. If you're stuck, just sit there and wait. But if you can do it, go ahead and try it. Who got that? Okay. Sure we got it before we move on. Questions? Okay. What's the next step? Expand and combine. You know what I did. Find your x's. 2ax can be x, it's 2a plus b. And your a is all by itself, so that has to be a constant. Anything that doesn't have your x with it is your constant. Okay. What's the next step? Match your coefficients. So this x coefficient matches this one. So I have, I'll write it up here. 2a plus b equals 8. Does everybody see that? That's your coefficient on your x term. The 2a plus b is the coefficient on the right, and the 8 is the coefficient on the left. They're equal. Then we have a negative a. That's your constant. That's equal to negative 3. I left a space here because in this equation, b is 0. That's all of them. Now, this should be pretty easy to solve. What is positive a? Positive 3. If a is positive 3. If a is 3, what's b? 2. See that? 2 times 3 is 6. You subtract the 6 from the 8, you get 2. B is 2. What do you think?
It's not bad.
Not bad. I mean, it does. I mean, it takes. It's easy once it clicks because it's just following certain steps. But until it clicks, you're just kind of struggling, holding on. But you want to see one more?
Wait,
Yeah, go ahead.
you do that again, how you got that?
Which part?
Yeah.
All of this up here?
Yeah, from there.
Okay, so
I understand how you got all that.
all of this.
Yeah.
But how did I get from here to there?
Yeah.
Okay, so this side is equal to this side. So all the positions have to be equal. So 8x has to equal this. And negative 3 has to equal this. So what am I saying? That these two pieces have to be the same. So 8 must equal the 2a plus b because the x is set. This x is not different than that x. So that means this must be equal to this. And then whatever thing's left over, you have to set that equal to this. Alright? Okay. We'll see another one when we turn you loose. Or I can help you while you're working on it. Alright, here's your assignment. Page 697. (13) through 16. All 4 problems. They're all case 1. You got 2 of the answers, and the other 2 you're going to have to work on.